So now that we've created that scatter plot, okay, let's look at it. We've been looking at regression equations and talking about curves of best fit, and we've been trying to figure out which curve might fit on here the best. So if I'm looking at this particular curve, right, if I would just draw a straight line through it, does that fit it? Not very well. We probably have a coefficient of determination, an r squared value that we were finding yesterday. We probably have one way low, like probably even less than that 0.18 that we had yesterday. You know, it's probably going to be like 0.0002. You know what I mean? Okay. So what if we went parabolic with it? Better, but bad still, right? Okay. All right. What if we went cubic with it? Still not great, right? What if we went quartic? Still not good, right? We're missing this whole section down here. So we came up with, in the last class, what power of a function is that? It's 8. There's 7 humps. Okay. 1, 2, 3, 4, 5, 6, 7. Wait. 1, 2, 3, 4, 5, 6, 7. Yeah, 7 humps. So that means it's an 8th power. Now, do you want to find an 8th power function? I don't want to find an 8th power function. So there's got to be a better way. And that better way is we're going to take this graph and we're going to split it up. I'd split it up into those 3 zones, right? Because now this first zone looks like it's what? What would fit in that first zone?
Cubic.
A cubic, right? Right? What would fit in this next zone? Probably a quadratic, right? Or maybe even a quartic, right? Get a little bit of a W in there. Okay? And what would fit in this last zone? Linear. Okay? Okay? Alright? So, this is what we're going to be developing today is something called, we're going to be able to put this as one function on our calculator. It's called a piecewise function. Okay? And it's called a piecewise function because it's a function made of different pieces. Okay? So we just answered some questions here. So from 1, because right here, this is 9, and this is 15, right in there. Okay? So from 1 to 9, you guys said that it was cubic. And I would agree with you. From 9 to 15, you guys said it was quadratic. And from 15 to 20, you guys said it was linear. Let's try this one. Okay, so here's the downfall now with that. Because we have this, oops, I never made it. Because we have this spreadsheet, or scatter plot, if you will, okay, because we have that, we need to now divide that up into 3 parts. And so in order to do that effectively, unfortunately, the downfall of the calculators is that they don't recognize just certain parts. So we have to make new spreadsheets. Okay? So we're going to go back here into this one. Okay? So now this is where we're going to follow along, and if I'm going too fast, you guys got to stop me. Okay? We're going to start a new column. Okay? In our new column, we can't call it X because we already have a column of X's. So I'm going to call it X1 because it's the first value of X's that I want. Okay? And now in there, I'm going to put in those first values of X's. We went from 1 to 9, right? So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? Then I'm going to go over one column. I'm going to go back to the top. Actually, I got to go all the way up and I got to label it. And we said that that was a cubic, right? Okay? So I'm going to put C in that column for cubic, because that's my cubic part. And then I'm going to go down. And now here, I've got to put in those corresponding values. So the first one was 2, then 10, then 17, then 20, then 18, then 17, then 24, then 30, and finally 38. Okay, so I put in the first 9 values. Now, what I can do is I can create a new page, and in that new page, I can do a new spreadsheet, or a new scatter plot, excuse me. So that's a data and statistics one. And so my vertical axis is going to be C. My horizontal axis is now going to be X sub 1. Or X1 is what we had. Okay? So there now is just the cubic part. Okay? So where down here on the next line, down here, it says fill in the function for each one. Okay? So what we need to do now is we need to find that cubic regression for just this part. And there it is. Okay? And so I would write that on this line right here. Find the function. So this line right here is where I would write that part.
How do you get to the equation again?
Well, we did it on the regression equation right there. It's right here. Okay? There's my regression equation. Now, another way that you could do it, and this is going to help you out later on, so pay attention here now instead of writing that down. Okay? I'm going to start a new page, and I'm going to add a calculator this time. And what I'm going to do in that one is I'm going to run my statistics calculation of a cubic regression. My X list is from X1. My Y list is from C. And I'm going to note here that it's dropping it in F sub 1. Okay? That's going to be important later on. So this just got dropped. This is my cubic, and it just got dropped into F sub 1. Okay? And it's the same thing. If you would look between, so an A value of 0.252525, 0.252525, a B value of negative 3.69805, negative 3.6985. A C value of 18.6447, 18.6447. A D value of negative 13.81, negative 13.81. So it gives me the same equation, it just drops it now in F sub 1, which is what I want. Okay? So let me go like this, and like this, because there it is. Okay? So this one got put into F1. That's a bad F1. So we got put into F1. Okay? So that was 0.253. Then minus 3.698. Then plus 18.645, and then minus 13. Yes, ma'am.
What should you like round to? Like, does it matter?
Doesn't matter. But the more you have, the better. But we left it all on the calculator too for us if we needed it. Okay? All right? Handle? Okay. Now we got to create one for our quadratic. So back into the calculator. I need to go back into my spreadsheet. Okay? Then I need to go, whoa. Got a little crazy over there. There we go. Then I need to go into my next column. And then this now is going to be my second x's, right? So that's going to be x2. And that x2 now is going to be from 9 to 15. So I'm going to start with 9, and then go 10, and then go 11, and then go 12, and then go 13, and then go 14, and then end it with 15. Okay? Then I need to fill in those corresponding data. So this data now is going to be my quadratic data, right? So what letter? Q. Nine was 38. 10 was 32. 11 was 29. 12 was 31. 13 was 30. 14 was 34. 15 was 40. Make me a spreadsheet now. Or, excuse me, a scatter plot now. Now my vertical is going to be Q, and my horizontal is going to be X2. And I want to do the quadratic regression on that one. Again, if I had to, I could go into my into my calculator page, and I could do the quadratic regression. I still want to do that, by the way. You can either create a new calculator page, or you can go into your existing one, and you want to put a quadratic regression in there. Now it's going to be x2 is my x list, q is my y list, and it's dumping it into f sub 2. It's telling me right here that it's dumping it into f sub 2, which is what I want. Okay? So there is my quadratic regression. So that's putting it in f2, and that function was 1.05. Actually, we'll call it 1.060 x squared minus 25.036x plus 177.048. Okay, now we got to do it for the linear, right? Okay, go do it for the linear now. See why when you get all these, see why it helps to have short, quick names for them, so that you can just type them in instead of scrolling down. So this one was, we'll put it in green, it dropped it into F3. I got negative 4.257x plus 104. Yes? Right? So the piecewise function then is going to look like that, okay? Where I have three parts to my function. And so what I need to do now is, in a piecewise function, this first part here is the function part. And this second part over here is the x values that you're going to use that function on. Okay? So, in this particular one, it was 0.253x cubed minus 3.698 x squared plus 18.645 x minus 13.381. And we were on that from my fives are. We were on that from 1 is less than or equal to x is less than 9. Right? Then we switch over to a quadratic. Minus 25.036x plus 177.8. And we're on that quadratic from 9 to 15. Notice that I can't be equal to 9 either here or there. Okay? I can't be equal to 9 in both. I can only be equal in one spot because it has to define which function that I go on at 9. Okay? So I cannot be greater or less than or equal to 9 in both cases. Okay? One of them has to be just a less than or a greater than. Okay? And then our last function is negative 4.257x plus 104. And I'm on that from 15 my thing just moved. From 15, whoa. From 15 until 20. Okay? So that now is my piecewise function. Make that look better. Can't believe I let it go that long. Yeah. Come on. Gotta be better at this. So the function part there. Yeah, we're good there. Okay? With me? Now, let's test it out on our calculator. Okay? So, because we've got it all in there, we're going to create a new page, but this new page is going to be a graph. Because now we're going to graph our piecewise function. Okay? So, in order to graph a piecewise function, you have to go to this button right there. That button opens up a shortcut to all of them. And the piecewise function is this one. It allows you to pick how many pieces you want in your function. Okay? So that's the one that we're going to do. And we're going to pick how many pieces for our function. We want 3 pieces. Okay? So what that does then is now you see it's opened up in our function that we're going to put in there. We're going to put in this now. Now, you may be saying to yourself, eyes here, don't start typing yet because you don't know how to do it. You've never done this before, so don't do it. Okay? Because you're going to want to type these all in, right? You don't have to. They're already in there. They're in there as F1, they're in there as F2, and they're in there as F3, provided that you did this right column stuff all along with me. If you did all of that right column stuff, it's all in there for you. If you didn't, you better start doing that right column stuff quickly before you do this part. Okay? Because now I can go in there, and instead of typing in 0.253x cubed minus 3.698x squared plus 18.645x minus 13.81, I can just type in f1 of x. And it's defined for me. Now, I just have to go over here, and I have to put my range in that I'm going to be using that function on. Well, that range was 1 is less than or equal to x is less than 9. Then I tab to the next one. And the next one is, instead of typing in that function that we just wrote out, I can just type in f2 of x. Tab over. This one's going to be from 9 is less than or equal to x is less than 15. Tab over to the next one. This one now is f3 of x. And this one is from 15 less than or equal to x is less than or equal to 20. Now when I hit enter on this, I only see that little bit of it. Why? No. Why do I only see that little bit? Is what, man? We gotta adjust the window. Yep. We gotta adjust our window. Okay? Because currently our window is going from x's from negative 10 to positive 10. On your chart, what do your x's go from? 1 through 20. Okay? So I'm going to go 0 here all the way up to 20. Actually, I'm probably going to go a little bit farther. Let's go 25. My y's on the graph go from negative 6.6 2/3 to positive 6 2/3. What do they go on your chart? 2 to 40, right? So let's go 0 to 45. And let's go by 5s. And there now is my piecewise function. Now, just to prove to you that it actually works, okay, I'm going to put in I'm going to make my scatter plot right on top of it. My x's were x, my y's were data. And there it is. Okay. Now, let's play around with that for a little bit here. A little bit. Oops. Okay. So, what can you tell me about how this fits? How my piecewise function fits my data? What do you think? Just a couple of little spots, right? We got a little issue going on right in here. That one right there is a little off, but otherwise everything's pretty close to being right on. Yeah? Okay. So I'd probably, I mean, granted, you can't do a coefficient of determination on a piecewise function for it. But if you look at it, we can go back here and we can say, all right, so our cubic was 0.9769. Our quadratic was, the worst one was 0.95. And our linear was, oh, look at that. That's pretty good. 0.998, right? Okay. So we got fairly close. Okay. You know what I mean? Okay. And there we go. Handle. Piecewise functions. If you turn your page over, now we're going to actually graph some piecewise functions. Okay. So if I am graphing this piecewise function, I'm going to take each piece separately. Okay? So, looking at the blue box now, and the blue box only, if you have multiple colors of pencils right now, or pens, now would be a good time for them, because then you can follow along and alternate your colors. Okay? So, looking at that one, what kind of a function is it? Linear, right? So that's going to give me a line. Refreshing my memory from way back in Algebra 1, how do I graph a line? Okay, how do I plot the points? What? It is in MX plus B format, yes. That's going to be helpful to us.
Plot 3 and then use your slope from there.
Can I ask you a personal type question?
Yeah.
Did you pull 3 out of a hat?
No, I just saw that. That's 2x plus 3.
2x plus 3. So the 3 then is the, do you remember what we call it? The y-intercept, right? Okay. So that's going to be a y-intercept of 3, right? And then my slope says how much? 2. So how do I graph a slope of 2? And don't use the word over. I will go ballistic if you use the word over. Because I know up, down, left, and right for my directions on a 2-dimensional graph.
Up to right.
Kenneth?
Go right 1 up 2.
Right 1 up 2. Okay, or up 2, right 1. And then rinse, lather, and repeat, right? Keep going. Okay? What if I don't like going up and to the right? Down 2 and left 1. Right? Okay? But now before you draw your line in, okay, you're going to want to go both directions. Okay? Before you draw your line in, you've got to look here at the restrictions on x's. What are the restrictions on x's saying? Less than 0. So that means that I'm going to take my, instead of a dot there, I'm going to put a circle there. Because it's less than. It's not equal to. It's just less than. And then which way am I going to connect the dots? Left or right? Left, because I want numbers less than 0, right? Okay, so that is going to be, blue, let's go that one. Okay, so that is the blue, the first piece of my piecewise function. Okay? Now I've got to go to the second piece. The second piece is this one. What kind of a function is that?
Quadratic.
3 minus x?
Actually, no, minus other two x's.
What kind of a function is 3 minus x?
A line.
It's a line again, right? Okay. So what's its y-intercept? 3. Okay. And then what's its slope?
Doesn't have to be just.
Again, I will go postal on you, Maddie, if you keep using
Wait,
that
what?
over word.
I said down.
And then you said over one.
Yeah.
Yeah, you did. Yeah. Yeah, call me a liar.
I forgot the word that you were.
Down one in which way?
Left or-
Down one and right one. Yep, down one and right one. Okay? If I don't want to go down one and right one, what's my other option? Up one and left one. Kids always are like, over.
I don't want to
I
say the
don't know
wrong
what
thing.
over is. Okay? I went to kindergarten. Yeah, don't get me wrong, it was back in 1980. Okay? But back in 1980 in kindergarten, we didn't have over. Unless we were playing Red Rover. Okay? Alright? So, now there's my suspected line. Okay? At 0 or greater than, right? So 0 is going to fill in. So that 0 then is going to fill in that dot or that hole, right? And then we're going that way with it.
Wait, wouldn't you go the other way?
No, because we want
That's not-
bigger than 0.
but that's-
That's bigger than 0. We're just looking at x's.
Oh,
Not
okay,
looking
that's-
at y's.
that's what-
Just looking at x's. Okay? And so there's my piecewise function. Now, I can evaluate my piecewise function. Okay? We're going to start bottom and work our way up. Okay, just so you know on these 3. Okay? If I want to evaluate my function at 2, am I in the blue part or am I in the red part? I'm in red because this is saying here that x is equal to 2. And x equals 2 is in the red part. Okay? So if I put 2 into the red part, what do I get? Three minus 2 is 1. So f of 2 is equal to 1. I could just look on my graph too. Okay? And my graph says at 2 here is 2, x equals 2. My graph is at 1. With me? Okay. F of negative 3. Am I on the blue part or am I on the red part? I'm on the blue part. So I have to put negative 3 into the blue part. 2 times negative 3 is negative 6. Plus 3 is negative 3. So f of negative 3 is negative 3. Again, I could go to my graph 1, 2, negative 3 is here, and I go down until I meet my graph, and it meets my graph at negative 3. Now, f of 0. Which part am I on? Blue or red for f of 0? No, I'm not on both.
Red because it's at or equal to.
Red because it's equal to. Okay? So I'm on the red part there because red has the equals part. So then this would be 3 minus 0 is 3. In this particular one, I still get 3 no matter which one I put it into. But if this were a discontinuous piecewise function, okay, here's an example. Here's an example of a discontinuous piecewise function because they go to different spots and they don't meet up at the same spot. Then it would matter which function I'm on. Okay? With me? I would like you now to graph that one. Why it does that, but it does. With me so far on the red and the blue parts. Okay? Now here on the green part, I'm still going to graph that line. I'm still going to start down there at negative 1. And then I'm going to use my slope of going up to right 1, up to right 1, up to right 1, up to right 1, up to right 1. I can go down to left 1 if I want. Okay? But I'm not going to pick up drawing that line until I get to x equals positive 2. So wherever my line is on x or at x equals 2, that's where I'm going to put my circle. And then I continue on with my line. Okay? So even though I have that x-intercept, I don't continue on with that until I get to that point. Okay? With me? So, evaluate the following. Blue, red, or green, where is f of -1? Which part is it on? It's on blue, so -1 plus 3 then is 2. So f of -1 is +2. F of +1. Red, blue, or green? It's on red, right? So that value then is 3. With me? Okay. Again, notice how there's no double equal sign at the same point on any of these. Okay? There was no double equal sign there when there was only 1 point, but over here there's no double equal signs. Okay? So, on this one it says, write the piecewise function. Okay? So, how many pieces does this function have? It's got 2 pieces, right? So, f of x here is going to equal a first piece and a second piece. And then you kind of draw the Alfred Hitchcock in between. Okay? All right? So, first piece, what does that one look like? Looks to be like a quadratic, right? So we got to think back to, what was that, chapter 2 or chapter 3 when we did quadratics? That was 2. Okay. Looks like it's got a vertex down here at the origin, right? So that's going to be y equals some a value times x minus 0 quantity squared plus 0, right? Now, we go through that point. Ooh, that's good because that's the point 1, 1, and that's the point 2, 4. So what's my a value?
2.
No. No. If it was negative, what would it look like, Matt?
The other way.
It'd be flipped over. So I know it's positive. Right? Anybody gonna take a shot? A value is 1. Okay? So this just is here x squared. Okay? Now I gotta give a range of x's. Well, it goes all the way up to 3. Right? Okay? So that's going to be x is less than 3. Next part. What's the next part? It's linear. What's its slope? So that gives me a slope of 3. So then if I were to continue that back, 1, 2, 3 over there, 1, 2, 3 over there. So now I'm at -2. 1, 2, 3 over 1 puts me at 0, -5, correct? So what's the equation of that line? 3x minus 5. So this would be, my second part here would be 3x minus 5. And what range of values am I going on? X is greater than or equal to 3. Now, what if you went less than or equal to 3 on the top one?
The other way around.
Then it would just be, so we could have that, or we could have
X is less than or equal to 3, and then X is greater.
that, right? But I can't have equals in both, and I can't have just greater than or less than in both. I got to have an equals in one of them for every number. Okay? You got purple tonight, purple's due on Monday. Okay?